Hello and welcome to Maths with Jacob. This lesson will focus on problem solving in sport, part 1. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. You will have an opportunity to subscribe to my channel at the end of the video. You are also invited to share this video with your friends. Thank you in anticipation. As I said earlier, this video is about problem solving in sport. It just shows you how mathematics can be applied to many areas in everyday life, and here I've picked a number of sports as an example. Let's look at cricket first. In 4 innings of cricket, Billy scored 34, 12, 16 and 40. What does he need to score in his 5th innings to have an average of 24? And here is the answer. All we do, we take the 5 scores and we divide by 5, and that should give us an average of 24. So here is the unknown score here at the end. So what we need to do is to solve this equation for x, and that gives us the score for the 5th innings. When we solve the numerator, we have 102 plus x over 5 equals 24. Multiply both sides by 5. 102 plus x equals 120. Subtract 102 from both sides, so x is 120 minus 102, so x is 18 runs. So Billy has to score 18 runs in the 5th innings to have an average of 24. Here's a problem for tennis. The approximate dimensions of a tennis court to the nearest metre are: the doubles court is 24 metres by 11 metres, and the singles court is 24 metres by 8 metres. What is the area of each of the above courts? Now, if we look at each of the above courts, they are just rectangles, and if you remember from my earlier video, the area of a rectangle is the length times the width. So for the doubles court, it's 24 metres by 11 metres, which is 264 square metres. For the singles court, we have 24 metres by 8 metres, which is 192 square metres. What is the ratio of the area of the singles court to the area of the doubles court? In simplest form. Now, the ratio is 192 to 264. And my earlier videos showed you how to simplify such a ratio. In this case, we just divide each of these numbers by 24, and the answer is 8 is to 11. That's in simplest form. Swimming. Now here is a diagram depicting a swimming pool, approximately the size of an Olympic swimming pool. They're normally about 50 metres long and about 25 metres wide. And most pools are around about 1 metre at the shallow end and around about 2 metres at the deep end. These are just approximate, but they're quite good approximations. And here's the problem. What is the volume of the above pool in cubic metres? Now the answer, the shape of the nearest face is a trapezium. So see this face here. If you look at it carefully, it's a trapezium because you have 2 parallel sides, one there and one there. There's the distance between them, and that's the 4th side here. So that is a trapezium. I have shown in an earlier video that the area of a trapezium is, you add the 2 parallel sides together and you multiply that by half the distance between them. So the parallel sides are 2 metres and 1 metre. The distance between them 50 metres, and you just halve that. So that gives you 25 metres by 3 metres. So that's 75 square metres for the area of the trapezium. So the volume of the pool is obviously this area here by that length, because that gives us the 3rd dimension. So it's 75 square metres by 25 metres, which is 1,875 cubic metres. From that, we can work out the capacity of the pool. So what is the capacity of the pool? That is, how much water will it hold? Well, you would have learnt that each cubic metre holds 1,000 litres. So, the volume of the pool is 1,875 cubic metres times 1,000 gives us 1,875,000 litres of water. So that's the capacity of the pool. Here's an interesting problem to do with a dartboard. Given the above dartboard, what is the angle formed at the centre by each sector? So basically we're looking at, for example, this angle here. That's just an example. That's one of the sectors, so we're looking at that angle there. Since there are 20 sectors, the angle at the centre is 360 divided by 20, which gives us 18 degrees. The reason I picked 360, you will remember, if you do one revolution of a circle, that's 360 degrees. Now here's another problem. If the radius of the dartboard from the centre of the bull to the outside wire is 170 millimetres, what is the area of the dartboard? We're allowed to use pi equals 3.142. So the area of the dartboard approximates a circle, which is, there's the formula for the area of a circle, pi r squared. 3.142 times 170 times 170, which is 90,803.8 square millimetres. And that's the area of the dartboard. Here's a quick quiz to help you, and please check through the video at any time. What is the meaning of the following? This is the answer to the puzzle. Back seat. I think you can see that. Quite straightforward, isn't it? Here are the answers to the quick quiz, and the video is at your disposal. If you found this video useful, please subscribe on the next slide. You will receive a notification when the next video is available. Please share with your friends. Hope to see you next lesson.